You sit down at a new job, open the repository, and stare at millions of lines of undocumented legacy code. No one knows exactly how the pieces fit together anymore. When codebases grow without a clear map, they inevitably tangle into spaghetti code. Modifying a single, seemingly isolated file triggers a chain reaction, breaking entirely unrelated dependencies across the entire system. Developers are forced into blind coding. You have to make structural changes to a massive architecture without a map to guide you, hoping your edits don't cause the build to collapse. And this problem is accelerating rapidly. We now have AI coding agents navigating these exact same undocumented spaces. They write and commit changes at machine speed, generating hidden technical debt faster than any human reviewer can track. Traditional documentation can't keep up. Static text files and manual diagrams are obsolete the exact second a new code commit is pushed. Without a real-time, constantly updating visual architecture map, developers and agents are forced to guess, making it difficult to predict when a routine update will destabilize the system. Codeboarding is an automated visual X-ray designed to instantly reveal the hidden architecture of any codebase. The hybrid engine begins with static code analysis, building a rigid map of structural dependencies directly from your files. But these raw, tangled clusters lack human context, so an AI agent layers semantic meaning over the logic, drawing boundaries and adding plain English labels. The system outputs highly accurate, human-readable mermaid diagrams and component-level markdown documentation directly into your project folders. This hybrid approach ensures that while the AI provides the context, its conclusions are anchored to the verified structure of the code, reducing the likelihood of architectural inaccuracies in your docs. Historically, setting up advanced code analysis required a frustrating amount of manual configuration, forcing developers to configure local language environments before running a single scan. Codeboarding uses an auto-managed deployment model, automatically pulling language server binaries for Python, TypeScript, and Rust with zero user configuration. But scanning a massive enterprise codebase repeatedly from scratch is paralyzingly slow, and it burns through expensive API tokens with every minor update. During incremental updates, the orchestrator isolates your commit, requesting analysis solely for modified lines of code. It updates the existing cache by rewiring immediate connections, leaving the surrounding massive structure completely untouched instead of rebuilding the entire model. This mechanical efficiency turns architecture mapping from a slow, quarterly manual audit into a frictionless, continuous background process. All of this processing happens quietly, feeding data directly to where developers actually work, the integrated development environment. Codeboarding's VS Code extension pulls these live architectural maps directly into your editor, allowing you to see the structural impact of your code as you type it. But the system really scales when you integrate this visual engine into your continuous integration pipeline via GitHub Actions. This image shows a standard pull request interface. When a developer submits new code, the GitHub action automatically generates and embeds a newly updated system architecture diagram front and center in the comment thread. Human reviewers can instantly see the architectural blast radius of a proposed change and visually inspect what the AI agent just wrote long before they hit the merge button. Constant, accurate visibility allows teams to manage technical debt as it happens, keeping the system structure clear even as the codebase evolves. Structural visibility functions as an automated utility within the development cycle. Check the link in the description to access the GitHub repo and subscribe for more.